This is a 3D LED cube I picked up on eBay. It uses 512 LED lights in an 8x8 matrix. And I'm going to solder the last matrix today and just show in a video how to do this in case you get a bit confused. The seller points you to a Google Drive with some documentation, and the documentation is not great. It's out of focus photos and a video that is not very clear. The kit comes with a bunch of LEDs. This is what's left for the last matrix, a chip, a remote control, and some other various components, and the circuit board. First step is really simple. They have you solder 4 larger LEDs. You got to make sure you use the larger ones. The ones for the matrix are a 3mm LED, and the larger ones are a 5mm LED. This is one of the 3mm LEDs that comes with the cube, and I want to show the short leg is the negative, and that's important because these are not like light bulbs. They only work if the voltage is applied correctly. So what I do is I fold the negative over just with my fingers, get it to be about 90 degrees to the LED. I then take a pair of pliers and I leave a little bit of space there, and then I fold this over. The reason you want some space here is this leg has got to clear the other legs when you solder this whole thing together. You don't want this leg to short out over the other leg that it's going to go over. So it's important to put a small amount of space here. The first step they have you do is solder some larger LEDs. These are 5mm LEDs. They don't mention that in the manual online. The cube comes with 3mm LEDs, but there's 4 larger ones that act as feet for this circuit board. So you solder these in place, which is straightforward enough. The board is labeled with the instructions on how to solder them in. Then comes the interesting part of soldering all of these smaller LEDs into the matrix, which is what this ends up looking like. It's a lot of soldering. You need some patience, and you need a good set of eyeballs, which is something that I'm a bit challenged with, getting things close to me. What they have you do is position the board upside down so the LEDs are going to act as feet, these LEDs here. Position the board so you see these minus signs or these dashes with these little extra foils here. Position the board this way. So when you put these in the matrix, the key is this lead can't touch this lead. So you have to make sure that they go over these leads. And by bending it slightly up on the positive lead where you leave a little bit of a gap, that will allow it to easily clear these leads so there's a gap underneath it, because you don't want it to rub, because if it rubs it's a short. It's not going to work. Then what they have you do is put the minuses towards you, and the pluses are going to go to your left. And then you have to, solder a hole. I would solder one set at a time, a set of 8. I wouldn't try putting these all in at once. I would do a row of 8 get them in place, and then solder them. So let me get a row in here, and then I'll come back and show you. Okay, so this is the back side of the board. I've put in 2 rows of the 3mm LEDs. The first row I soldered. The first row is a little tricky because there's nothing to anchor anything, so the LEDs move around, so it's a little bit harder to get them stationary so you can solder them. The second row is more interesting because I wanted to stress why it's important that you have to put a small spacing on the positive lead, because if you don't, these legs that are going to touch these legs. So that you have to make sure that this leg clears this leg, because if you fold the positive lead over flush with the LED, this will rub against this, and that's a short, and then it's not going to work. So it's very important to have a little spacing in there. For soldering, I use the 6040 rosin core, and for a soldering iron, I would recommend a 25-30 watt iron. Don't use any gun, 150 watt type stuff. Keep it low. So the next step is to solder some of these legs on. I don't know if there's any magic trick here. It's just there's some work involved in keeping these things stationary while you do it. I'm not going to obviously show me filming all 64 of this matrix. So I'm just going to put one leg on top so it's sitting there cleanly. Make sure you use some sort of a wet sponge on your soldering iron to keep the tip clean. Now this is obviously a little tricky with the camera in my way, but I will put the soldering iron behind the leg, put a little bit of solder on it, and here we go. We now have one leg stationary, and once you have some stationary, it's good. It anchors everything, and the rest of them don't move around as easily. You will also have to bend some of the legs to get them to position correctly. And then keep that iron tip clean with the sponge. I tend to like to do the overlapping legs first. And see, this one moved. And that's going to be the tricky part, because they are going to move while you're soldering. So make sure the overlapping leg sits on top of the leg next to it. I would not solder it to the side of the leg, because you want to make sure these legs clear the negatives, because otherwise you will get a short. So sometimes it's a balancing act to get it to stay up there. Alright. Then for the negative legs, what I like to do is fold them in here. Make sure they're sitting flush on the LED. If they're not, I've been using my pliers to put a weight on it, and then hit it with some solder. And that's it. When you get a completed set, what I recommend doing is just run your finger down on each wire and make sure it doesn't break loose, or maybe you missed a solder joint. I had a couple that actually popped loose. I didn't have a good solder joint on them. So I recommend this, because once you start assembling this, I think it'll be a lot harder if one pops loose once it's all together. It'll be hard to get a soldering iron in there. So you have to check up and down on each one. I also, when I solder this, I do a row at a time. I don't put all the LEDs in and then solder everything. So I put a row of 8 in and then solder them. Less likelihood of missing a joint that way. Now, popping this out is actually a little tricky. It doesn't want to come out too easily. So what I do is I just push the dimples on the other side with my thumb, get them out like this. Then I took one of these edge connectors that came with it, which is going to be what we solder this all together with, and get it underneath there. This one popped out pretty good. Some of them don't pop out quite so easily. Oh, next step is to test these. If you have a multimeter, I've got an old Fluke, you want to put it on the diode setting. That'll provide some voltage to the LED, and then you can see if they light up. So I would highly recommend doing this. This is the 8th one I just built. One of them had a bad LED, and it was no fun unsoldering that from the set and then replacing it. Now here's the other nice thing. This particular kit, these are my leftover LEDs, so they give you quite a few. So if you mess up, or there's a few bad ones in the kit, they give you plenty of extras. Nice touch. So put it on here with your lead, and then test each one. The camera's probably not going to pick up them lighting. I've got a lot of sunlight in the back of me. But run it down each one and make sure they light up. Because you don't want to put this all together and then find out you've got a bad LED. Alright, the next step after soldering all those LEDs together is to solder some of these components to the PCB board. There's not that many components here. We have a chip socket. Make sure when you solder this that you do not have the chip in the socket. You don't want to have that in there. Make sure you solder it without it. There's 2 audio jacks which go over here on the board. There's no questions there that they go there. There's some sort of a header jack. I'm not sure what this is used for yet, but that's going to go over here. There's some sort of a transistor or rectifier. According to the picture that I got on eBay, this mesh on the transistor goes outward on the board because there's no other polarity markings on the board itself for those 3 pins here. Then there's a input power jack. That's going to go over here. So that looks like pretty simple soldering. When soldering the chip socket to the board, you're going to need a really fine tip on your soldering iron. Something like this. Don't want to use any chisel tips. There's not a lot of room between these connections, and you want to make sure you don't bridge any of the solder joints together. So be careful there. Some of these components, it's going to be hard to keep them on the board flush while you solder it. I am going to use some masking tape to help hold this down. So when I flip this over, it's going to sit square on the board and it's not going to move, and it'll just be easier to solder that way. I'll be doing the same for the audio jacks and the power input jack. So this is the board finished for the component side. The resistor is not polarity based, so it'll go in either way. The masking tape helped with some of these connectors to keep them flush. The socket does have a little dent in it, so they want you to put the dent with the marking on the circuit board. So the final step here, or not the final step, but the next step is to solder all of these little pins into the circuit board. There's 64 of them here to solder in, and these are what's going to hold the LEDs in place. Okay, so soldering these pins onto the back of the board was easy, no big deal. They go in nicely. When you solder them in, they square up all by themselves. You don't have to position them and get them true. As you can see, they went on nice and square. The next step, which is the last of the soldering, are these little edge boards. Now the documentation shows an arrow on this board right here. That arrow is going to line up with the back side of the board. So if you look at the board, you'll see some arrows here. So you make sure to line those arrows up when you solder this in place. This, I think, is going to be a little tricky because the spacing between these connectors is pretty tight. Alright, the next step with these riser boards, it's a little tricky getting that thing to stay in one place. So I found a piece of plywood that was about the right thickness to put underneath here so that the board doesn't drop to the bottom. If it drops all the way to the bottom, you won't have enough on the top. Then I used a pair of third hands to help hold it from wobbling around left or right. The manual says this fits in there with a tight fit. It does not. It's a very loose fit, so it's very sloppy. So I put some heat shrink on the clips to not damage the board, and then the third hand helps to keep this thing from going back and forth. Then you have to bend the leads over to solder them to each point. Once you get one lead soldered, which is what I have done here, it's anchored. At least you've got something to hold it in place and it will go. But the tricky part obviously is you want to try to get all of these LEDs somewhat square. And I don't know if I'm going to end up like that or not. We'll see. Okay, the final step is soldering the risers to the circuit board. There's 4 foils down here, and there's very little spacing between these foils, and they have to be soldered from here to there on both sides. So there's 8 in total times the 4 risers. So it's going to be interesting to get that solder on there without causing a bridge. There's not a lot of spacing between them. Okay, next step was a little confusing, which is the remote. It requires a CR2025 watch battery. It did not come with one. When I popped out the holder does not fit this battery. There's an insert in here for a much smaller diameter. So what I found is by playing with this, you have to fatigue this off and break off these inside pieces, and then you'll be able to fit your battery in there. Okay, it's done. I'm actually a little nervous about plugging this in. I gotta straighten out some of the LEDs. They're not very true. I'm still not clear what to do with this thing. There's this little board. It has a USB port on it. It has a button. Red and white LEDs. I got no clue what this does. It came with a USB to a little power jack here on the side. I brought my Anchor power supply in that I usually use to charge my cell phone and my tablet. I shut off the shop light, that's why it's a little bit darker in here. I'm going to kill this light and we're going to plug it in. Wow. I can't tell if every LED is working. It's going a little fast, but this is way better than I thought it was going to be, turning this thing on. I think I've got a dead row right here. I have not seen that row light up. Yeah, it's dead. So we got to figure out why that row is dead. I don't know what this button does. I'm going to try pressing it now. Doesn't seem to do anything. It just toggles this red light on and off. Oh, I just noticed the base also has some color LEDs on it. So I guess it's time to figure out why that row is dead. I'm hoping it's just that row. It's hard to tell with all this blinking going on. Okay, after working on this for a while, I was finally able to fix all the dead slots. The remote, what you do is, when you turn it on, let it gyrate for about 10 seconds. Press the number 2 key. When you press the number 2 key, every light will light up. Then you can write down more easily which rows are dead. I had several dead rows. It's hard to identify with it dancing around. You need to see every light on so you can tell exactly what row is shot. In my case, the dead rows were all because of these riser boards. They're a little tricky to solder. You've got to get the solder to travel upwards, which is the difficult part. That's these guys right here. Oops. You've got to be able to get the solder to travel upwards. If it doesn't travel up here, it won't make a connection. What I finally did was, when I had a dead row, I put my voltmeter on the diode setting and then figured out what trace is what row. So let me show you. Like this trace here, the first one, is row 1. You can hear the meter beeping. So the second one is row 2, and so forth. In my case, it was the 8th one, which was back here, which is the very top row. that was dead. So I was able to just, apply more solder to that connection. So that's the easiest way to figure out. Instead of reheating every connection, figure out which one belongs to which row. And in this case, it's 1, 2, 3, 4, 5, 6, 7, 8. It goes in that direction. So then you can narrow down more quickly which connection you have to reheat and put more solder on. I still don't know what this other board is, but you don't need it when it's in standard animation mode. I'm not sure what this board does. Maybe it's some sort of a programming board, I'm not really sure. The worst part about this kit is the documentation. It's terrible, which has been commonly complained about on the articles that I found online. And nobody on YouTube had this particular build. So it was just play around with it until you get it. But it's neat. I'm very happy with it. Get this in a darker room and film it. It'll look better. I have a USB amp meter. I was curious how many milliamps this is going to draw with 512 LEDs. And it's drawing about 173 milliamps. This is the cube all finished. I ended up going back to the eBay seller and I bought the Plexiglass kit for it. This also is a pain in the butt to assemble, but it's worth it. Keeps everything dust free. It also gives it a better glow. It just looks better. I've been running this now for almost a year, 24/7. It's still going strong. It's a real conversation piece. It's not expensive. A lot of fun to build. I recommend it, especially if you like the solder. This is something fun. Just as a note, this is a vintage Heathkit clock from the mid-70s that still also is working. And it's fun doing soldering projects like this. If you like my video, please subscribe. Thanks.